Module 4, Expressions, Linear Equations, and Linear Inequalities. This is section 4.10, Solving Inequalities. Before we start solving inequalities, let's look at some symbols. When you have the carets pointing left and right, the one with the small part to the left is less than, and the larger part to the left is greater than. If it has a bar underneath, that means less than or equal to, and if it's the other direction, it's greater than or equal to. After we're done solving the linear inequalities, we'll also graph them. If it's a less than or a greater than, you'll use an open circle. If it has the or equal to on the bottom, you'll use a closed circle. You can tell the difference between equations, inequalities, and expressions by the symbols. If you have an equation, that means you have an equal sign. If there's no equal sign, but a less than or a greater than or equal to, or a less than or equal to, then you have an inequality. And if there's no symbol at all, those are expressions. You can see in the first line here, 3x equal to 9, 4x plus 3 equal to 9x minus 6. Those are equations because they have equal signs. 3x less than 9, or 4x plus 3 greater than 9x minus 6 are inequalities because they have the less than or the greater than. 3x and then 4x plus 3 are just expressions because they don't have any symbols at all. Let's solve one. When you have an expression, you're going to solve it exactly the same way as an equation. So if this had said 4 plus x is equal to 12, I would have subtracted 4 from both sides. I'll still do that, except I'm not going to have the equal. It will just be minus 4 minus 4. And I'll be left with x is less than an 8. Since there's lots of numbers less than 8, we also graph this on a number line. You'll use an open circle when you have less than or greater than, and you'll use the closed, so more like a dot, when you have less than or equal to or greater than or equal to. So for x less than 8, I'll sketch a number line. It doesn't have to go to or from any particular number. It doesn't have to include 0 or negatives. I try to keep the number that is in the inequality towards the center, just so I have some space to draw. This is a less than, so I'm going to need to use an open dot. You put it either right on the number line or you can put it above. And then you're going to say, well, which side do I need to shade? Is 7 less than 8 or is 9 less than 8? Well, of course, it's 7 is less than 8, so I'll shade this direction. Those are the numbers that will make that statement true. And it'll look something like that. 48 is greater than or equal to an 8m. If this was 48 equal to 8m, I would divide 8 on both sides. So I'm going to do that here as well. 8 divided by 8 is a 1, so I'm left with just m. And 48 divided by 8 is 6. Well, 6 is bigger than a lot of numbers, so let's go ahead and graph this. If I want to graph, I'll put the 6 kind of towards the middle. It doesn't have to be perfect, so I have it kind of towards the end here because this is the number that I have in the expression. And 6 is greater than, well, is 6 greater than 5 or 6 greater than 7? Well, 6 is greater than 5, so I'm going to wind up heading this way. But I'm going to need to put a closed dot this time because I have the or equal. And now I can go ahead and shade. 6u is greater than or equal to 36. Divide both sides by 6, and I got u is greater than or equal to a 6. Let's put a 6 towards the middle. 7, 8 this way. 5, 4 the other way. Closed dot. Is 5 greater than 6? No. 7 is greater than 6, so I shade this way. 3y minus 1. Well, now I'll need to add 1 first and get 3y greater than or equal to 6. Now I could divide, and I get y is greater than or equal to 2. I'll put the 2 towards the center go a few up and a few down. Doesn't have to be many. This is a closed dot because I have that line underneath. And is 1 greater than 2 or is 3 greater than 2? Of course 3 is. And so I shade that way. X less than 12, if I want to sketch this, I'm going to need to figure out if I need an open or a circle. Open or. If I want to graph the inequality x minus 12, first I need to think about, do I need an open dot or a closed dot? Then I need to think about which direction I need to shade. Well, this is going to be a open dot. And then I'm looking for numbers that are less than 12. Well, these are less than 12, so I'll head this way. So sometimes you just have to graph. 42 is greater than or equal to m. So this one's going to be a closed circle. And I'm going to have to get numbers that are actually smaller than 42, right? Because 42 is bigger than the m, so this is going to be closed. And 42, is that greater than 41 or 43? So it's going to be this way also. Notice that they're both shaded the same direction, but the arrows are pointing different ways. It has to do with where your variable is. Pause the video and see if you can try graphing these. Here are your answers. Closed dot, we're looking for numbers greater than 3. Open dot, numbers less than 7. Here are two to try to solve and graph. Pause the video and see if you can get these. Here are your answers. For the left, we'll need to subtract 8 and then divide by 2. So I get x is less than a negative 2, and I'll have a closed dot, and then I want numbers that are smaller than negative 2. On the right, I'll just need to add the 5, so I get g is greater than 7. I'll have an open dot, and I want numbers greater than 7, so I'll shade to the right. Sometimes I have to right solve and graph. So I have 5 times a number increased by 4 is greater than or equal to 34. So 5 times a number, we'll just say 5 times x. That's increased, so that's a plus, by 4. That's greater than or equal to, so this side is bigger than or equal to the 34. Now I could solve. So let's see. I'm going to want to subtract 4 from both sides. So I got 5x is greater than or equal to 30. Divide both sides by the 5. I have x is greater than or equal to another 6. I got a lot of 6s today. 6 in the middle, 7, 8, 5, 4 the other way, closed dot, and I want numbers greater than 6, so I'm heading this way. And that's how you solve and graph inequalities.